We are continuing the chapter pressure is question and answer. And at this time we are solving some numerical problem related to the chapter pressure. In this chapter we have some numerical problem related to the pressure in which we use P equal to F by A, pressure equal to force by area, to solve the numerical problem. There is another type of numerical problem which is related to Pascal's law. Normally a spherical vessel is shown and the area of different pistons are given, and somewhere force is also given, and we have to solve the numerical problem related to pressure, force and area using Pascal's law. Another type of problem related to upthrust and another hydraulic machine. There are different hydraulic machine, hydraulic lift, hydraulic jack, etc. And the numerical problem related to this machine also we are going to solve in this chapter. Okay, let's start with one of the numerical problem. This problem starts with a diagram, and what is told: if the area of the piston M is 0.05 meter square and that of N is 0.15 meter square, what force produces in N when 40 Newton force is applied in piston M? Okay, let's have the given. Area of piston M is given here 0.05 meter square, and area of N, piston N, is also given 0.15 meter square. If we take area of M as A1, then we have to take area of N as A2. Okay, another information is force at M, that can be represented by F1 is 40 Newton, and we have to find out what force on N, F2. This is a very easy numerical problem, and this type of easy numerical problem usually comes in the examination. That's why I'm solving this problem. According to Pascal's law, pressure on M is equal to pressure on N. So we have an equation: pressure exerted by piston M is equal to pressure received by piston N, F2 by A2. Okay, now taking the value, F1 is 40 Newton, A1 is 0.05 meter square, F2 we have to calculate, and 0.15 meter square is the area of A2. I mean to say area of the piston N. Now I want to take this 0.15 to left hand side, and then F2 becomes alone, and F2 is equal to 20 Newton into 0.15 meter square divided by 0.05 meter square, and the result is 120 Newton, because meter square cancel, and multiplication and division gives the result. The force which produces on the piston N is equal to 120 Newton. That's why we can write one sentence for this. Therefore force on N is 120 Newton. Let's have another numerical. The value of force and area of the piston is shown in the given diagram. According to the given information, calculate the area of piston Y and the force on the piston Z. Until and unless we have diagram, we cannot answer this question. Let's have the diagram. This is the diagram given. Now what the question? We have to calculate the area of piston Y. Here force is given, area we have to calculate, and the force acting on Z we have to calculate. Area of Z is given but force is not given. So first we have to write the given information. About the piston X, we have given force on piston X, which can be represented by force on X, Fx. This is equal to 225 Newton, and area of the piston X is also given, that can be represented by symbolically Ax, area of X. This is equal to 30 centimeters square. What about Y? Force on piston Y is given. Fy means force on Y, it is 200 Newton, and another information also is there. Area of piston Z, AZ, area of Z is equal to 5 centimeters square. Each of the symbol is taken in such a way that it has meaningful relation with the piston. Okay, now our question is area of piston Y, AY equal to question mark, and force on piston Z, that is Fz equal to question mark. Now we have the same equation. We have what? Fx by Ax equal to Fy by Ay is equal to Fz by Az. It means pressure exerted by the piston X is equal to pressure received by piston Y, and the same is equal to pressure received by piston Z. We have to be very clear that pressure on all this piston is same, equal. Okay, now I want to take the value. Look at this. The value is taken fx 225, ax 30, fy 200, ay we have to find out. That's why the same symbol is written. Fz we have to find out. The same symbol is written. Az is 5. Now we are going to find out first ay. Where is ay? Here it is. That's why from the relation of first and second, first means this first piston x and second piston y, relation between them is equal to what? This is equal to 225 by 30 equal to 200 by ay. Now we can calculate ay. Ay equal to 200 into 30 divided by 225, and finally we'll get 26.67 centimeter square approximately, because I'm taking just 2 digits after the decimal point. Let's have another solution. Again, from the relation of first and third. What it means first and third means piston x and z. If we relate these two, I mean to say fx by ax is equal to fz by az is if taken, then we can write this 225 divided by 30 equal to fz divided by 5. Now we are going to calculate fz. Fz is equal to 225 into 5 by 30. We'll get fz is equal to 37.5 Newton. This way we can solve the numerical problem. It seems to be a little difficult at first, but when we write the given information, the same numerical becomes very easy. Okay, after the solution of the numerical, we have to write one sentence. It will be better to have a sentence. So the area of piston Y is approximately 26.67 centimeters square, but the force on the piston Z is 37.5 Newton. Okay, now let's have some other question. Look at this. With the help of the given diagram, answer the following question. This question was asked many times in the final examination, even in SLC, SE, etc. That's why I am taking this question. After the diagram, question is asked like this: which principle is proved by the given diagram? Actually, a polythene bag is taken, it is full of water and it is squeezed. And when we squeeze the polythene bag, it has a lot of pores. We can consider that all the pores are receiving the same pressure. So we can say that it is related to Pascal's law. The principle is told, but actually we have to write the law because this is related to Pascal's law. Now second question, state the principle. Now we are going to write the Pascal's law. Pressure exerted at any point in a confined liquid transmits equally and perpendicular to all the direction. Let's have another question. Name the device based on Pascal's law. There are many devices. They are hydraulic lift, hydraulic brake, hydraulic jack, hydraulic press. Now remember hydraulic. Hydraulic means it is related to water. It is hydraulic lift or brake or jack or press. All these devices are called hydraulic machine. So at first I want to tell you about the hydraulic machine. Exactly what is hydraulic machine? Let's have the question. What is hydraulic machine? Hydraulic machine is a device based on Pascal's law which magnifies the force. Have you noticed that? 2 points are highlighted. One is Pascal's law, another magnification of force. Including these 2 points, we have to define hydraulic machine. It is a device which is based on what? Pascal's law, and it is used to magnify the force. Now let's have another question. Draw a neat diagram to show hydraulic machine. We can draw this diagram. Look at this, very simple. A small vessel is connected to a big vessel by means of a narrow tube, and it is filled with liquid, and a piston is given to each of the vessel. Okay, now another question. How a hydraulic machine is constructed? It's very simple. Looking at this diagram also, you can say that a small vessel is connected to big vessel and it is filled with liquid, and piston is given to each of the vessel. We can write this way. Hydraulic machine is made by connecting a small vessel with a big vessel by means of narrow tube which is filled with a liquid, and a piston is fitted at the mouth of both the vessel. Okay, now let's have another question. How a hydraulic machine magnifies the effort? Explain thirdly with the help of the diagram. In the definition of hydraulic machine, what was told? It magnifies the effort. But how? For this, it will be better to have a diagram first, and we can say that we apply force on a small piston which exerts pressure in the liquid, and the same pressure transmits to big piston, but the area of big piston is very huge in comparison with a small piston. Because of this huge area, the same pressure produces very huge amount of force on big piston. We are writing this way: when a small force is applied on the small piston, it exerts pressure on the liquid. According to Pascal's law, the same pressure transmits to the big piston, but the same pressure exerts a huge amount of force on the big piston because the area of big piston is very huge in comparison to the small piston. Thus, a hydraulic press magnifies the force. Another question: write down the equation used to solve the numerical problem related to hydraulic machine and name the symbols used in the equation. This is the formula: F1 by A1 equal to F2 by A2. With the help of the hydraulic machine, we can understand this formula very clearly. We are always applying force on the small piston, which is called F1. That's why we have to write F1 is force acting on the small piston, because meaning of the symbol is also asked. That's why I'm writing meaning. This force is acting through this surface area, and this surface area is called area of the small piston, and this is represented by A1. Because of this force and area, pressure produces in this liquid and it transmits to the big piston, and a force acts on the big piston that can be represented by F2. So in the formula, F2 is force produced on the big piston, and the area of the big piston, this is represented by A2, and A2 is area of big piston. Okay, let's move forward. Now mathematically prove that hydraulic machine is an effort multiplier. If you are told to prove this mathematically, then it will be better to have a diagram, but you don't have to make diagram in the examination. In previous class also you were asked just the formula and the meaning of the symbol used in the formula. We don't have to show the diagram in the examination, but I am showing diagram to you to make you clear about the subject matter. Let's say in this diagram, this is the area of the small piston, and we are going to take a value for it. Let's say it is 1 meter square. And so I can write that the area of the small piston A1 equal to 1 meter square. And the area of this big piston, let's say this is 25 meters square, we can write area of big piston A2 equal to 25 meters square. In this hydraulic press, when we apply force on the small piston this way, 100 Newton, then its effect can be seen in the big piston because it exerts pressure in the liquid and that transmits to the big piston, and certain amount of force produces in the big piston, which can be denoted by F2. Okay, this can be written this way: if an effort of 100 Newton is applied on the small piston, then according to Pascal's law, same pressure transmits to big piston. Now the force exerted on the big piston can be calculated by following equation. Which equation? F1 by A1 equal to F2 by A2. In this answer, we have created different value for F1, A1 and A2. And then with the help of which we can calculate F2. If F2 comes used, then that of F1, it proves that hydraulic machine is effort multiplier. That's why I want to use all this value. Look at this: F1 is taken 100 Newton, A1 is 1 meter square, A2 is 25 meters square. We are going to calculate F2. F2 comes what? 25 multiplied by 100 becomes 2500 Newton. Meter square and meter square cancel each other, and the final result is 2500 Newton. What it means? We are applying just 100 Newton force, but the same is magnified to 2500 Newton at big piston. This way we can prove that hydraulic machine is an effort multiplier. At the end, it will be better to have a sentence for this. Thus, 100 Newton effort magnified to 2500 Newton. It proves that hydraulic press is an effort multiplier. Okay, now I want to stop here. We'll meet in another class with some another matter.